Alright, let's just continue from where we left off with the forces on a charge. Now I want to look at the force on a current, which is just a bunch of moving charges all moving in the same direction through a wire. And that current is placed in a magnetic field, it experiences a force. And that force is going to be the current times the length of the wire, the vector kind of pointing along the direction of the current, cross product with the magnetic field, so it's going to be the force is I times L times B times sine theta, where I is the current, L is the length of the wire, and theta is the angle between them. So right-hand rule number 2 is very similar to the first one, but basically instead of your index finger being the velocity, it points with the current, which is the velocity of all the individual charges. Then you have your other fingers along the direction of the magnetic field, and your thumb is the force. So in this case, with no current, what we have here is the current is either going to be up or down, so you're going to orient your hand one way or the other. So if the current is going up, you point your hand up parallel to the screen, and the magnetic field is in. That means the force is going to be to the left, and it pushes the wire off to the side. Then if we flip the direction of the current, you can flip your hand upside down, curl your fingers toward the front of the screen, and then your thumb has to point to the right. So that's the direction of the forces when you have an electric current. All right, we'll come back to these a little bit more for Monday's lecture. Those will be posted later this week. Thanks a lot.